and welcome to another high-powered episode of the High Voltage Live Show. I'm your host, Willie Snyder with Nat King Code, coming to you live from the Mile High City in Denver, Colorado. I am joined by my awesome partner in crime, Mr. King James Stallcup, coming to you from the Longhorn Country in Big Tornado Twister, Texas. And he is a CEO of the Volt Online Academy and creator of the High Voltage Live podcast. So awesome for you to join us and help us out with this, James. And I love all the material you bring to the table every week. I've tried to do it by myself, but it's boring. You guys would hate it if it was just me trying it. But it's a lot of fun. I really appreciate the participation. We had a great week, NEC for Dummies. We're at over 32 now, over 32,000 members. We're bringing such awesome content. I'm doing the code question of the week. So you guys are studying for your test. If there's some certain areas you feel like you're weak at, let me know. I'll tailor a question for that area that you want to cover. A lot of people been hitting me up saying they want to do more hazardous locations. So I'll try to, moving forward, try to find some more hazardous location questions and go off that. Is a lot of awesome comments this week on the myth of the week. That the myth this week was actually spurred from one of the Facebook posts, and I told the guy on there, I was like, well, I'll run it for myth of the week. I'll get you a solid answer, So that's pretty awesome that I can, get the expert opinion in the room and kind of help me out with busting the myths. And, we try to tie a bunch of stuff in, and so I really appreciate you working your tail off, James, to get these all put together. It's really awesome, and I know you seem like you like the myth or the meme I picked this week.
Yeah, let me go ahead and run it. I started laughing when I saw it.
All right. So the thing that's so funny is we always say you have to do like 2 ugga-duggas, and so it's always funny because my apprentice, he's always stripping screws out, and I was like, oh, you just put too many ugga-duggas on it, and he's like, what? And I was like, yeah, you only needed 1 ugga-dugga and you put 2 ugga-duggas on it and stripped her out, but I've actually seen apprentices break bolts before, and it's like, dude, why'd you use so many ugga-duggas, So it's pretty funny when you say that, but I am kind of a little bit of a nerd when it comes to the torque specs. Like I could pretty much tell you every single piece of equipment what torque it's supposed to be, and like a lot of guys, I'll tell them when you look at like how you torque a breaker, it's about 20 inch-pounds, and 10 inch-pounds is about the pressure it takes to open a door. So if you can picture that as being 10 inch-pounds, it's about double what it takes to open a door. So you don't want to be too much like I've seen apprentices just reap them. I've seen apprentices put their impact on them, reap them all the way to China. And I've actually seen them where you couldn't even get the screw back out after they impacted it. We ended up having to throw breakers away because they were impacted all the way shut and you couldn't even do nothing with them. So you got to be real careful when
Where did those torque specs come from? Or the torque specs on how you should torque something come from the NEC or the manufacturer?
I would believe it would come from the manufacturer.
Of course it does. And once again, that's where you take and use the manufacturer's instructions. And that's going to lead us right in to when we start talking about the myth of the week. And that's why I wanted to bring that little portion up. Because the manufacturer's instructions, if it's a listed and labeled product, is going to override what the NEC says in the discussion. And
I agree.
That's where we're going to get into this myth of the week. And, we did this a while back where I went in and I actually went in and showed using UL and how OSHA views it. And OSHA specifically tells you that those manufacturer specifications, everything when it gets its listing and labeling is done to provide what? Safety. And that's where we're going to get into this, and we're going to discuss the myth of the week. So I'm sorry to
And
interrupt you, but I wanted to bring
no,
that point up before we get started.
no, and that's a really awesome point. This is, and we could actually run this one for a minute too. People think that the torque specs is a new code. It is not new in the code. It has been in the code for a long time, and we might actually have to do that as far as see if we can figure out how far back it goes. But that would be kind of a fun one for everybody. But it's 11014D, I believe,
That's
and
correct.
when you go into that, there's a lot of stuff that has torque specs. I mean, you wouldn't believe all the things that actually have torque specs. A lot of people just think, no, when you tighten those lugs, you just got to get them as tight as possible. No, that's not true, because you can actually over torque equipment. So, awesome meme. Whoever I stole that from this week, it was in one of the groups. So appreciate me stealing your meme for the meme of the week. And I guess we'll roll the myth.
All right, here we go.
It's time for Myth of the Week.
Right, that song gets me every time. I swear they're saying myth in there. But so this comes from a post that was in NEC for Dummies. A lot of people probably saw it. A guy said he was arguing with the inspector, and it says in the manufacturer instructions that it can be installed in short raceways. It gives you a UL number in there, and I went and actually looked that UL number up, and I didn't see anything that said it could be installed in a raceway. Now, there's a difference that this ideal might be saying that you can splice these in short raceways, but that's in a dry location. So where this guy was talking about, he was repairing this. So what happened was the gentleman said that the general contractor cut a line. I don't know exactly what it was. It was probably a branch circuit that fed out to an outbuilding. Well, they tried to pull the wire out, but it was stuck. It wouldn't move. So they decided to use this ideal inline splice and splice it just for like 12 to 14 inches to the other J box, and then make the re-splice it there. Well, I guess the inspector somehow saw him. I don't know. That was the other part. I didn't really understand how the inspector got involved. Maybe, I mean, I know if you're the inspector at Grapevine, James, and you're walking by and see some dude splicing inside a conduit, you might have some questions for him.
I would have.
But but it was pretty awesome that we were able to kind of pick this up from this individual and run it for the myth of the week, because it was a pretty valid point. Now, what I would argue, and I've done this before with inspectors, is I've actually went and got the UL. I looked up that UL number, and if you have something from the manufacturer that says this is listed and labeled to be installed inside a wet location conduit, I could see the argument. The problem is the inspector is going to say those splices have to be accessible. And if you have to remove 12 inches of dirt to access that splice, then that's not going to be compliant. So it was pretty awesome that we were able to run this week. And I really appreciate you putting it to light, James. And let's get the old inspector angle on it from your perspective.
Well, I started looking at I actually went over to UL 486C. That was the main UL standard you wanted to go at. And I also looked at what Ideal had here. And the first part of it up there is inline design allows splicing of solid stranded and small raceways. But then when you look down below that, the only thing I see that they're recognizing here is that this is a number 18. And I'm thinking that the conductor cannot be larger than number 18 here. It has to be a number 18, and it gives the max force, uh, uh, which is 3 pounds, and it says if you're at a half inch KO, you can do 3 of them, and if it's a 3/4, you can do five, up to five.
Oh wow.
And I
Okay.
I was sort of looking at that, and I don't think everybody looked at that closely. I didn't read all the comments or anything on there. I didn't have time, but that is one thing I would point out here is this is not just any size conductor from what I can tell.
Right.
And I think this is for number 18, and they give you the numbers here. And if you look up above where it has the features and benefits, it talks about compact size enables three to fit through a half inch KO simultaneously, and this is a low insertion force. Okay.
Right.
And those were the things I was looking at here. And then they had the next part of this that I broke down here. And I started looking at this and I was like, well, now if you look at this, it changes a little bit because it tells me the wire range size was solid 12 to 20 AWG. So
Right.
as I started looking at this, I was like, okay, this is interesting because then when you get into the 10 bonded here, they start telling you about the strands and everything here and what they're going to permit. And then they show you where they have the KO opening. And the way I'm sort of looking at this, it's not so much it's in the raceway, it's right there at the raceway, a small raceway where it's coming through and you're making that connection right there at the KO. And
Yeah.
if you look at that half inch KO opening, that's what it looks like it's talking about to me. So
True.
I'm not saying, even though it's in the raceway some, it's really where they're talking about is making the connection where it's at the KO and the conductors were too small. That's what I
Okay.
think they're talking about here.
Okay. Yeah, and like I say, a
So
lot of people were like, I had some funny comments. Were like, "Is that false advertising for my deal?" I was like, "It could be, but I can guarantee this is not a product listed for installation in a wet location."
no, I agree with that. I am curious. Did anybody make any comments about it being in the KO or the knockout
Uh,
is?
no, we didn't get it. I don't think any of them said that.
Okay,
We didn't have very many people. Like I say, everyone nailed the myth of the week this week. There was all the comments were pretty radical as far as the inspector's right. Whatever he says is right. Well, if you're the inspector, then I agree. But there's some other inspectors out there that don't have as much knowledge and code knowledge as you. And like I say, I could see if you could find something that says that this is listed in a wet location to be. And like I say, it could be something in that case, like you're saying, where it just needs to get spliced and pushed in the KO a little bit. Maybe that still
that's
could be considered accessible.
that's what I'm thinking this is. And because I'm looking, when I looked here where it's got the dimensions, it's specifically showing where it's in the KO right there. It's not
Right.
saying it's in the raceway. And if you
Right.
go back and you look at this right here, they're basically telling you where it's small raceway, but it's also talking about compact size enables three to fit through what a half inch KO simultaneously. And I think what
Right.
they're talking about is it fitting in that KO, and then you have some that's in the raceway there. I don't think this is something where you're just making a splice inside. You made a splice and pulled it through the raceway. I don't think that's the case here. I think this is where you had a short conductor or something, and you're making a splice right there where the KO is. That's what I think it is. But
I agree.
I
I'd agree with
uh,
that.
I don't know how everybody viewed this or what their interpretation was, but the way I'm looking at this and the way that this is set up and the way they're showing this is in the KO. This is not in the raceway. I mean, it is in the raceway a little bit, but it's really at the KO where this device is being used.
Well, and I'll have to look that one up because I think we did do the myth on the 6 inches of free conductor, because there was a myth where people thought that the 6 inches of free conductor didn't have to be spliced or couldn't be spliced, that it had to be 6 inches of free conductor or else you had to repull the cable. So we busted that myth a while ago. I'll have to go through. Just so everyone knows, I am going through and making my Myth of the Week a podcast. So if you guys want to check out the Nat King Code podcast on Spotify, I'm going to start doing them all in a podcast form so that you guys can kind of check these out, kind of go through them. We'll give you the UL. I'll try to give you the UL numbers in the podcast in all that different stuff to kind of, so you can go look up the supporting documents and stuff like that, kind of dig into them a little deeper. But it's freaking awesome, James. I think you're 100% right that we've actually had this happen before in some remodel jobs where you only have like an inch of wire, inch of conductor to work with coming into that J box, and these would kind of work out good to just give you that extra little bit that you could splice onto, because you can't tell the customer you're ripping their whole wall out because you only got an inch of wire.
Yeah, I think that's what this is dealing with here. And it is a UL product. It's listed and labeled, and it has a catalog number and everything. And I personally think that that's what it's actually used for. I don't think it's really, can you just install it in the raceway? I think it has to deal where you're making this connection, you don't have much wire, and you're having to go where that KO opening is, that knockout opening. I think that's what this is.
Well, and we've had this before too, where you've had some of those lit mirrors. They're like lit mirrors, and there's all kinds of crazy mirrors that you can install now in the hotels and stuff. But these are some of the products that you use. Is you actually, let's just say you have a conduit coming into that mirror, then what you're doing is you're taking those splices and you're kind of shoving them back into the conduit, and then you hang the mirror.
Sure.
So it's not that splice is inaccessible. It's just shoved back in that raceway a little bit. And then if you wanted to take that mirror down, you could still access those splices.
Sure. I think that's what this is about. I don't think this is just saying you can just do a splice in a raceway. I don't think that's what this is saying at all.
Yeah, and just for everyone, this myth is busted. You cannot splice in the raceway up underground. So basically, that's what he did, was he was trying to splice in a PVC that was going underground, is my guess. He didn't say it was exactly PVC. It could have been EMT, but it was some kind of raceway that went underground, and they tried to just splice about 12 inches just to get them through and get their, because they said the wire was stuck when they were trying to pull it. They said it wouldn't pull out, but they didn't have the truck either. I could have got it out of there.
Well, I am curious. Did anybody even look at it from the knockout perspective? Because that they're very specific on those, how many can be done through a knockout, and have anything to say about the raceway. That's why I think that's what they're talking about.
Well, and I went and looked up that UL number, and the only thing that it referenced was how the splice is made.
That's it.
It didn't say anything about going into a raceway or anything.
It doesn't.
But, like I say, there is probably solutions that you could come up with in that case, where you could just put like a Carlon box on the other side of the sidewalk, or like a grade box, and then make your splice in there and repull it from the grade box over to your other box or back to wherever it is. You're always gonna have a solution when you have like experience. And James, you ran into this, and like, okay, so if I was on that job and you came over and you're like, hey dude, you can't splice to that conduit, I'd be like, hey, do you have any other ideas what I could do? This is kind of in a parking lot. Is there any kind of boxes that are rated for this or whatever? And this is that the GC is the one that messed this up. So this is kind of on the GC's ticket. So if you said, you know what, they make a traffic box that's, rated, that goes in the, asphalt, whatever. Like, that's what's so cool about getting along with the inspectors is you can just ask them for solutions, and you're gonna be like, well, I'm not your lawyer or anything like that, but there's some products over here at whatever, you could say, I don't even know off the top of my head, but you could say, at suchandsuch.com they have some solutions that might help you out. You know what I mean? Like, you're not gonna tell us like, oh, hey, this is what you need to use, because then if all of a sudden we use the product you tell us to use as the inspector, then we're going to come back and be like, oh, inspector told me to use, green products, you know what I mean? Like, oh, you never said to use green product. You just said, there's some solutions that you could do kind of like this. So that's kind of why I like doing this from kind of like an inspector perspective versus I would be, more of the, foreman in that situation. Like, what are we going to do? I'm going to tell the general contractor, like, hey, this is our options. This is what the code says. The code says you can't splice in a raceway. We're not going to be able to just fix this for you unless we do X, Y, Z, Right. So it's kind of a two-way street when it comes to the foreman involved on the project and, like the inspector, whatever inspector saw this. I agree with that inspector. I mean, I would not allow that to fly, and it's going to be hard if it doesn't get fixed. Then it's going to get worse and worse and tougher, and you might run into some red tags and stuff like that. And nobody wants to deal with that. So,
all right.
Yeah, well, awesome. Thanks for putting that together, James. Appreciate it.
Yeah, it might be good to go on the where the people were commenting on it and ask them about the KO, because I think that's what it's all about. I don't think it's about splicing in the raceway.
I don't think we really had anybody that was 100% advocate of splicing the raceway. I mean, except for the original poster, which thanks a lot for bringing it up there, sir. And like I say, I hope we helped you kind of come up with some solutions. If you have any more questions about it, or you want us to figure out some way to help you fix it, like I say, I have no problems going through my big bag of tricks and coming up with some way to get her fixed, code compliant. So,
all right.
Thanks, James.
All right, let's roll the topic.
Uh-oh.
All right. Now, this week we're going to be covering GFCI protection for boatyards and marinas. And before I get started, this was sent to me, and this was some audio from Ryan Jackson. And I'm just going to say right now I disagree with what he says, and I'm going to show and explain why I disagree with what his interpretation is. So let me go ahead and play this audio so everybody can hear it, and then we'll go through and look at the sections and see if what he's saying is correct.
Other outlets. Outlets that do not supply shore power must have GFCI protection if they're supplied by branch circuits rated 150 volts or less to ground, 60 amps or less, or 100 amps or less if it's three-phase. All right, so you've got ground fault protection of equipment for the boat. You have GFCI protection for everything else. So here's my regular old receptacle. We would just follow the typical rules in 210.8b. It's outdoors, it's got to have GFCI protection. But even if that rule didn't exist, this rule says, listen, outlets that don't supply shore power still have to have GFCI protection. Now, we have to be careful with the word outlet in this section, because it doesn't say receptacle outlets, it doesn't say lighting outlets, it just says outlet. Remember that an outlet, as defined in Article 100, is a point on the premises wiring system where current is taken to supply utilization equipment. So it's not just receptacles that require GFCI protection. That would include lighting outlets as well. So if I have luminaires on my dock, on my boatyard facility, I've got to have GFCI protection for those as well. If I have hardwired equipment, remember hardwired equipment terminates at an outlet where the hardwired equipment meets the premises wiring, that's the outlet. So it's not just GFCI protection for receptacles, it's GFCI protection for just about everything that's on that marina or boatyard.
Oh yeah, everything, man, just everything. Just
Okay.
GFCI everything.
First, I wanna bring a point up here. He says at a point where it receives its supply is the outlet, and then he says at the receptacle, like if you were cord and plug connecting it. Well, first of all, a receptacle is a device. It's not an outlet. There's a reason that we have a definition for a receptacle outlet, which is the box, and then you have a definition for a receptacle. The outlet is the box, okay? And that's why these terms are going to matter when we're looking at this. He's making a blanket statement that anywhere that you just pick up current, that's an outlet. That's not correct. And I've been saying this over and over, and this particular section here that we're dealing with that deals with the ground fault protection of equipment and GFCI for personnel protection, they've got them separated here, and they're specifically calling out receptacles. And the reason they are, because a receptacle is a device where it's receiving its current, but the receptacle outlet is the box. That's where the outlet is, okay? It's not the receptacle, it's the outlet box, and that's where your cord and plug connected. Matter of fact, if you go look at Article 316, the very first word in there that deals with all your different boxes and everything, it says outlet. Okay.
Oh, you're talking about 314.
I mean 314, Article 314. I'm sorry.
Yep.
Now, let's look at the section, see what it says here. It says, for other than floating buildings, ground fault protection for docking facilities shall be provided in accordance with 555.35A through D. Okay?
Yep.
So if you look at A is where we deal with a feeder, and it says listed ground fault protection of equipment rated not more than 100 milliamperes shall be provided for feeders installed on docking facilities. Coordination with downstream GFPE shall be permitted at the feeder overcurrent protection device. Okay, now, first of all, unlike what he said before, he says a feeder, I could, like if I was going over and hitting a fusible type disconnect, and then I go to a single motor, he says that's a feeder. That's not correct either. That a feeder, I've already showed that, is where you go to two or more items. That's when you're taking a feeder. So in other words, if I'm going over there and I'm going out to a dock and facility out there where I'm going to have a whole bunch of different boats, and I go out there with a feeder to a panel board, that panel board's that's the feeder going out there to that panel board. Everything that leaves there, unless I'm feeding two or more items, I'm feeding a single item going out there, and that's going to be a branch circuit. Okay? No matter how I set it up.
Yeah, and there was another thing that he was incorrect on, and I don't know if it was in that clip, but there is devices out there that can be dialed down from 100 milliamps to 4 to 6 milliamps.
Sure,
he was saying that's a Class A device. That is not a Class A device. If it has a dial on it and you can dial it, it is not a Class A device. That is a Class E device. So,
that
was another incorrect statement.
Now watch this. This is interesting. If you look at B1, it talks about receptacles providing shore power. Now, he already made the statement, I've got a receptacle that's out there. He's saying, your cord and plug connecting something, that's an outlet, therefore I need to provide Class A protection. Basically, everything is considered an outlet. It shouldn't matter what this says right here, because he says it's an outlet anyway, no matter what I go to. Well, here, they're telling you receptacles, All right. That means I'm
Yeah.
going to be cord and plug connecting something. Is that correct?
Yes, sir.
Okay. And it says, if I'm going to shore power, it says listed ground fault protection of equipment not rated more than 30 milliamperes shall be provided for receptacles and installed in accordance with 555.33a. And that's where if you already provided upstream with a feeder, you're okay, right? And then you
Yeah.
can dial it down whatever you need to match it. And if I go back and look at 555.33a, it says it will not be rated more than what? 100 milliamps. So that ties
Yeah, and
into what you were just saying.
yeah, there are devices out there that you can dial from 100 down to 30, and he was saying, well, you could dial them down to 4 to 6, but I've already ran this through with some pretty top people in the industry, and they basically say that just because that device can dial down to 4 to 6, that does not make it a Class A device. That's still a Class E device for equipment, regardless if you could dial it down to 4 to 6. It's
Sure.
not doesn't change to a Class A device.
No, it doesn't. And then it talks about outlets for other than shore power. And it says outlets supplied by branch circuits not exceeding 150 volts to ground and 60 ampere single phase and 150 volts or less to ground. It says here 100 amperes or less three phase shall be provided with GFCI protection for personnel. Okay. Now, that is where you're going to be setting up, just like I do for shore power. These are going to be cord and plug connected type devices. Okay.
Right.
This is not going to be something that's hardwired. And that's where the problem starts coming in. And that's why I
Yep.
say this also. If it is the case, like he's saying, right there where it receives its supply, there would be no need to have a definition for a receptacle outlet because you've
Yes, sir.
already stated that the receptacle is where I'm picking my point up, not at the outlet, but at the receptacle, which is a device. And if I'm hitting a device, that is where I'm cord and plug connecting, and I'm taking and I have personnel that has interaction at that point around a wet location. If it's hardwired, the personnel doesn't have uh, 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 any type of
Interaction.
interaction with it.
Yep. I
Okay.
agree.
Now, let's go a little bit further. Then, if you go in and you look at this, it talks about the receptacles and how you mount them and everything. And when you come down and you start looking at the different things, it talks about the enclosures for shore power receptacles. And look at
Yeah.
here. Receptacles intended to supply shore power to boats shall be enclosed in listed marina power outlets. Enclosures listed for wet locations or shall be installed in listed enclosures protected from the weather. The integrity
Right.
of the assembly shall not be affected when the receptacles are in use with any type of booted or non-booted attachment plug cap inserted. Now, let me ask you this. They're telling you you're going to be plugging that in. And you've got your
Yep.
shore power set up there, and they're telling you got to have a listed marina power outlet. Now, why all of a sudden, if I have the equipment that's plugging in there and I'm providing the GFPE for that, why wouldn't I need GFCI protection also?
Right.
It's a receptacle, isn't it?
Oh yeah.
That's my whole point here. And then if you look at the branch circuits in Pren 3, what does it say? Each single receptacle that supplies shore power to boats shall be supplied from a marina power outlet or panel board by an individual branch circuit of the voltage class and rating corresponding to the rating of the receptacle. Well,
Right.
looky there. You just told me that when I go over there and I'm picking up uh, uh, my connection there to a receptacle, that's an outlet, and I've got to have GFCI protection. So is he going to say not only do I need GFPE, but I also need to have GFCI protection for the outlet that's out that I'm plugging into for the shore power?
Yeah. That you see, and that's pretty much my argument. We've actually made this argument before with EBSE because EBSE says there's protection for personnel, but it's not Class A, and so that's where you run into problem when they're saying you have to have Class A ahead of the Class B, which the whole thing is they don't tell you what class it is on the manufacturer instructions because it just says personnel protection for it says personnel protection provided. Now, I did some research on a little bit more on this EBSE stuff. Dude, there's so much safety devices, and like they have a little pin connector in there that basically it has to make contact with the vehicle before it actually discharges energy. So there's so much like safety stuff in there that there's no reason that you have to, provide Class A for that upstream outlet that they say exists. And another interesting thing that I'll just tell everyone, all the viewers out there, is that the individual branch circuit, if you go look in the definition, it says connects to utilization equipment. So technically you start at the breaker or fuse, final overcurrent device, and ends at utilization equipment. There's nowhere does it say it ends at an outlet.
Yeah, and I'll take it a step further. And nobody will answer this. But don't worry, there's a lot of proposals that are going to be coming from me. If you go look at the definition of a branch circuit, it says it can supply what? An outlet or outlets. Now, if I can go to just an outlet, then that's an individual branch circuit. Okay, because you're supplying one piece of equipment. Why did they feel the need to go in and say for an individual branch circuit, being very specific that goes to what? Utilization equipment. The reason is because it's hardwired. Now, if you go back and look at the definition of a branch circuit, it says it can go to an outlet or outlets. And if I just go to one outlet, it can just be an individual branch circuit. But if you're going, or if you want to call it an individual branch circuit, but another interesting point, somebody said, well, if you go look at 422.16 B43 and you go over there and pick that up, it says you can have an individual branch circuit. And I said, exactly. I said, but you left out the most important part. What is that individual branch circuit feeding? It says a receptacle. And a receptacle is going to be put where? At an outlet, which is the box. And that's when you're cord and plug connecting. So when they are clarifying some of these individual branch circuits, they're basically taking it from the definition of a branch circuit, and they're basically telling you, you got to have a receptacle there. Otherwise, they don't mention receptacle because you're connecting to what? Utilization equipment. Yeah. Okay?
And
which
like
is hardwired.
When you look at like these window units, somebody mentioned it, one of the J-Dubs at the Jobsite, really appreciate, shout out to you, brother. He mentioned like, why does a window unit have to have an individual branch circuit? And the whole thing is, it's like, they're only drawing like 5 amps. Why can't it's not like it could be continuous, but the thing is that if you have that set on like a thermostatic control, there's not a guarantee that AC unit's going to run for 3 hours or more,
Yeah. And plus you go look at, it's a good point. What does a window unit have there? It's got to have GFPE. Yeah. And the equipment, if the equipment's having a problem, that's what's going to protect you. Why, you got the AC unit, it's at a window, it's outside, it's getting rained on and everything. Why don't I have GFCI for that receptacle there?
Yeah.
I mean, you just, and that's what I'm saying. There's certain equipment, they tell you to have GFPE protection, okay? And it's the equipment that's providing the protection. And I'll add another point. Co-making panel 2 went in, and then they come back after the fact and said, oh yeah, the AC unit, there's an outlet there and you got to have GFCI protection. Well, wait a minute.
Oh, you forgot the language, the charging language. Most likely there's an outlet there.
Well,
they said most likely.
There's no most likely. There's not one there, but I'll take it a little further. They didn't have the technical merit to even make that kind of change. there were no deaths or anything from the AC unit. And I've heard them come in and say, well, the AC manufacturer needs to get their equipment fixed. No, the AC manufacturer doesn't have to do anything. Their
Yeah.
equipment is designed by UL, and it has a listing and labeling on it. Matter of fact, the new standard that's coming out the 1st of January 1st, 2024, they got it down now to where it's 10 milliamps. That still is not going to fly for GFCI protection. Matter of fact, if you go in and look at the substantiation that was given during the Standards Council process review, the Standards Council completely rejected the TIA from the code-making panel 2 wrote, and code-making panel 2 rejected what the task group did, and they're basically telling you that's not going to happen. It's not.
Yeah.
Their equipment's not going to work that way. Well, then the Standards Council said, now, wait a minute. They did all this stuff down in Houston and did all these different AC units. They actually provided substantiation. Code-making panel 2 didn't provide no technical merit at all. So basically, I feel like everything they did to 210.8F and then started saying this, they did something that wasn't correct. And I will tell them that I'll tell them to their face. You did not have the technical merit to make that change. And
well, yeah, and just to let everyone know, the equipment was not designed by UL, but the equipment manufacturers are actually using a UL standard. So UL has all these different standards about how the compressor's wired, how the how the contactor's installed, what it's tapped to, what leakage current, where the leakage current goes to. And this whole leakage current thing, I believe, is an afterthought that they thought this is going to save us and we're going to be able to prove our argument that this equipment has leakage currents. Well, then what do they run into? Freak drives. Oh man, freak drives. Oh man, freak drives don't have leakage current. But what the variable frequency drives are doing in these pieces of equipment is they're basically ramping your motor up slow. So that's where you get your high efficiency units. So what's happening is you don't have that solid inrush of like 30, 40 amps that a lot of times what we have to do like 10s on a 50. We don't have that 10s on a 50 kind of inrush. So what they're doing is basically that variable frequency drive is basically like a dimmer for your AC unit where it's turning it on, but it's turning it on slow. And when it does that, the Class A device freaks out and trips because it sees that dimmer action actuating and it doesn't know what's going on because it sees an imbalance between the grounded and ungrounded conductors, or actually the grounding and the ungrounded conductors, and then the GFCI activates, thinking that there's a problem when it's not, just the AC unit's going through its cycle of ramping up to turn power on.
Sure.
And so this has gotten to be a problem in a lot of places. I saw something earlier, James. I thought it was 109 down there where you're at today.
It's hot.
But I don't think I'd be wanting my AC to trip. And then I was talking to some people today at the gas station that had a Tesla, and they weren't getting gas. They were just at the gas station. But I was like, yeah, how would you feel if your Tesla charger tripped while you're sleeping? And yeah, they didn't really like that. So, that kind of thing, it's pretty funny. Like the look of horror was like, why would we put it on a GFCI? And I was like, well, there's certain people out there that says you have to or else you're killing babies. But the whole thing is that I do not want to downplay the tragic incident that happened to Von Tralpergo. That was very tragic. There's a lot of, I feel that this whole thing should have been dealt with a lot earlier. If this child died in 2007, for them to come out in 2020 and put it in, I just think is not right. There's not been a hazard. I could see if there's been a hazard since 2007 and there's been 2007, 2014, even if there was just 2, and they say that there's 2, there's 3, there's 4, whatever. These guys were HVAC techs working on an energized, not locked out, tagged out.
That's right.
You can't. The code that was not what the code is for.
That's right. And I'll say this: the incidents they referenced had nothing to do with the equipment. It had to do with improper wiring and improper maintenance. And that does not give you the right to make a change and require something when the equipment was not at fault. And what they did, in my opinion, was underhanded to say that was the reason. And there's going to be some clarification coming in 2026. And, I've already I'm putting in, you need to delete the definition for an individual branch circuit, the definition for a motor, the definition for a general purpose branch circuit, and the definition for multi-wire branch circuits. And the reason you need to delete that is because everything has an outlet anyway, and a branch circuit already covers it. And there's a reason those definitions are in there. And for them to come in and say, oh, well, those definitions, you got to use the definition of a branch circuit with that. No, you don't, because it's already an outlet anyway by y'all's thing. And let me say another thing. Ryan's saying, oh, where the wiring method connects to the equipment, there's where the outlet is. You're going to tell me I have an outlet that's just free floating in an infinite space there?
Yeah.
But yet I need to clarify what a receptacle outlet is, for instance.
Yeah.
There's already an outlet. Why do I need to clarify that? This is picking and choosing to use your argument. But I'm going to regress on that for a minute. I want to go to this next part.
Dude, did I tell you that I put one in for individual branch circuit? Because individual branch circuit's the only definition that doesn't say outlet. So what I submitted was to add the term outlet to individual branch circuit and then say that's what the utilization equipment connects to.
Mm-hmm.
And I don't think they're going to like that one.
Yeah, and I want to put another part on this. Also, it's interesting. When you're looking at the receptacle, that shore power receptacle is, when you look at 4A, it tells you that receptacle is rated at 30 amps and 50 amperes and shall be of the locking and grounding type. That means it's going to lock in. There's a reason that the receptacles are designed a certain way. And and basically what they're telling you is you're not really going to be as the owner of that slip, cord and plug connecting that, you're going to be doing that to the unit that's there, that's providing the shore power. And that's the reason that there's no GFCI protection. You know what amazes me about this? If I'm plugging into that receptacle, why are they so specific, saying all my other receptacles have to have Class A GFCI protection, but when I go to the receptacle for shore power, it doesn't? But yet I'm going to allow to have my GFPE protection at the equipment or the feeder upstream.
Yeah, and that's a good point, James. In kind of in layman's terms for all the people watching, what we try to do is we try to selectively coordinate this for the safest install possible.
Sure.
So what we're doing is we're doing the 100 milliamps upstream on the feeder. Then that's going to a 30 milliamp, and then what we're doing is we're going from the 30 milliamp to the 10 milliamp.
That's
so
right.
in essence, you have these pieces of equipment GFCI protected in some way, actually GFPE protected, but
right.
you have Class A protection at your locations that are for protection for personnel. You have your shore power that's for protection of equipment, which just to make people understand, protection of equipment means if there's a problem with that equipment, that's gonna open that overcurrent device prior to human contact. So the Class A device is based on human let go. So if you have a lot of human interaction with something, I think, yeah, cool, it's probably a good idea to have Class A protection. Like one of the good examples of this is a dryer. and I've always argued this with a lot of guys, with why isn't a dryer outlet required to be Class A protected? Well, under 2023, 210.8D as specific appliances. There was a lady and her daughter that were both killed on a dryer. And I guess what happened was, I don't know if it was the daughter or the mom, they got hung up on the frame of the dryer. The daughter tried to save her or whatever, and they both died. To me, that's a good change. That right there is like, yes, that dryer has a ton of human interaction. I've seen kids actually jump inside the dryer before. You know, I think that is great to have Class A protection for that. You have a box on the side of your house that nobody ever touches, and you're saying that that needs the same rules as that dryer. So that's where I think this is kind of ridiculous.
Sure, I'll take it a step further. You know, when they go to the receptacle other than shore power, Class A protection, and we agree that the receptacle is a device, right? Okay.
Yep.
Now, if I have a breaker trip, why don't I have upstream at that breaker? Because you got a panel board that's got a feeder going out there to it. Why doesn't it have GFCI protection? That's a device, isn't it? And that's my whole point. You cannot just pick and choose where you want to classify the receptacle, you know?
Right.
And that's why I've been trying to say those are devices. That the outlet is the box. You see what I'm saying? And when you got a panel board, that panel board's not an outlet. Okay, it's an enclosure that is housing all your different devices. And all you got to do, if you know, you look at that breaker. What is that breaker? It's a disconnecting means. Is that correct?
Oh, yes, sir.
Sure, just like a switch. Well, when you pick up a disconnecting means, it says a device, a group. It's a device or a group of devices. Okay. Well, if that panel board's a group of devices, and you go pick up a device, it shows a disconnecting means, switch, receptacle, circuit breaker, all these different ones. And that's what I'm trying to say. It's not an outlet. And for them, you know, I've heard them come in and say, oh, well, if I take the receptacle, put it in there at the receptacle outlet, that's all one part. And therefore, the receptacle is the receptacle outlet. No, it isn't. Okay. I could very easily take and put a switch there. Okay. I could do all kinds of stuff there. And for them just to go ahead and just willy-nilly just say, oh, well, that's a part of the outlet, the receptacle. No, it isn't. Okay.
Dude, don't you be stealing other people's willy-nillys on me, all right? Because there's a lot of other people that want to get me on willy-nillys, all right? But you can't patent that, all right? It's already taken.
Now watch this. This one is where they come in, they say other than shore power. This is time back. It says receptacles other than those supplying shore power to boats shall be permitted to be enclosed in marina power outlets and the receptacles that provide shore power to the boats, provided the receptacles are marked to clearly indicate that the receptacles are not to be used to supply power to boats.
Nice.
I mean, how much more clear can this be? I mean, it's going through, and when you look at the heading, it's specifically telling you receptacles. Okay. Yeah. And the reason they're saying receptacles is because the receptacles are being mounted in the receptacle outlet. It's not at the end of the equipment. Okay. Yeah. And not once, I looked through this whole Article 555, not once did I see anywhere that it mentioned about any other equipment and there being a GFCI protection. It all deals with receptacles and the receptacles that are installed in where. It's telling you, in this case, it says enclosed in what? A marina power outlet.
Yeah, so just to
I mean,
just to keep everyone in layman's terms, you could have two receptacles in this box and in this outlet, and you have one receptacle outlet that's got 30 milliamps GFCI protection and one receptacle outlet that has 4 to 6 milliamps GFCI protection. And this is basically saying you can have those encased in the same box as long as you say that that receptacle that has the 4 to 6 milliamps is not to power boats.
That's right. And if
Am I
you look
correct?
at this, they're very specific that it's installed in an outlet. That's what gets me. And then they have specific requirements how high above the deck surface it needs to be due to your electrical datum claim.
Yep.
I mean, all of this, and that's what I'm trying to point out to everybody. You just can't just say, oh, well, everything's an outlet. Well, if that's the case, then why do they have to be specific about the receptacles being installed in an outlet?
Well,
You see
yeah,
what I'm
and
saying?
me and you, we uncovered the one on EBSE because EBSE in the manufacturer instructions said GFCI protection is not required if you hardwire it, because it said the only time GFCI protection would be required is if you cord and plug connect it, because if you go into 625, I think it was 40, 62540 or 62530 something, it says all receptacle outlets must be GFCI protected. It doesn't say anything about hardwired being an outlet.
That's right. And look at this. They even go a little further. They talk about boat hoists here. And it says GFCI protection for personnel shall be provided for outlets, okay, not exceeding 240 volts that supply a boat hoist installed at docking facilities. And then it tells you GFCI protected receptacles for other than shore power shall be permitted to supply boat hoists. They're telling you it's a receptacle. I mean, I don't know. I regress on this because everything that I'm reading here is going straight in to talking about receptacles. And then when you pick up D, it talks about the leakage current measurement device. And it says, where more than 3 receptacles supply shore power to boats. I'm going to stop right there. I don't even need to go through all this leakage current and all the information notes because it specifically says, once again, what? Receptacles.
Yeah.
Now,
what are those receptacles connected to? The receptacles are connected to a standard branch circuit which supplies one or more than three, you know, and then look at that.
Yeah.
Effective January 1st, 2026, you know. See, that's the whole thing. They push this stuff out. We don't even know. Like, that expiration might not even be realistic.
Yeah. And that's been my whole point behind this is when you look at everything that I've talked about here, everything dealt with what? A receptacle. And then and then I started at the first with the feeder about GFPE, and then I did the GFPE for shore power, and then all these other connections is where it's talking about going to where? A receptacle. It didn't say anything about it. Well, it did say outlets, but it said a receptacle that was installed in a marina outlet.
Right.
I just don't know how much more plain that can be. And then it talks about ground fault protection. And then it says the main overcurrent device that feeds the floating building shall have ground fault protection not exceeding 100 milliamps. Ground fault protection for each individual branch or feeder circuit shall be permitted as a suitable alternative. And then it says outdoor outlets, shore power outlets, and boat hoists located at floating buildings shall, looky here, comply with what? Where we started, 555, 35B through C, which says they're what? Receptacles.
Yep. And what we run into here is, and this is kind of a really good way to illustrate it, James. I really like it. If you look at, like, let's just say this building, like we were talking about this a little bit. You have like a building that, like, they're selling sandwiches or something. Now you have a hardwired AC unit out there. And you don't have Class A protection at that building on it, but guess what you have? If for some reason, if for some reason something happens, you have 100 milliamp GFPE on that. That 100 milliamp GFPE is going to save somebody's life on that AC unit.
Sure it is.
Because what happens is if you have a problem, which In the case of Montreal Pergo, he jumps the fence, he lands on the AC unit, 100 milliamps trip, Montreal Pergo walks home.
Mm-hmm.
You know? So a lot of people try to say that this kid would still be killed if it was a 100 milliamp overcurrent protection device. That is straight lies.
That's a lie.
Yep, I agree.
There's a reason. I mean, look at them. They allow GFPE for shore power. That's around water constantly, but yet it's not okay for an AC unit. Give me a break.
Okay.
I don't agree with that.
I agree. No, really good way to present it. I think everyone learned a lot. That was awesome. I learned a bunch. I didn't really see it with that kind of spotlight when I watched Mr. Jackson's presentation, but I think there was a different kind of glasses he was wearing that day when he made that. It was a little different. It didn't seem right to me. So
you've got to look at the full spectrum of all those sections. You just can't assume anything. And when you look at that, and you know, he pulls out this part, but he doesn't go back here and get the other portion of the receptacles where it says it has to be in a marina outlet box. Okay, and it specifically tells you that there's no ambiguity behind that. It specifically tells you that, and the reason it tells you that is because the receptacle is installed in where? The outlet box. And what's so interesting, it calls it an outlet box. I mean, how you can all of a sudden just say, oh, well, it covers all outlets, and then you pick another outlet. And I'll say this, if the receptacle's at the end where it takes the current at that point, why is there a need to even identify an outlet box? I mean,
it's already there. It's already there anyway.
But it's not. And that's my whole point. And that's and I'll give the code making panel a lot of credit that put all that together, because they specifically understood that the box was the outlet that the receptacle was going into. And that's why they said the different type of receptacles, regardless if it was just for GFCI protection or GFPE, that it was connecting at a receptacle that was in the outlet box. It specifically stated that every way. So in my opinion, it goes back to what I'm saying. Anything that's hardwired, that's a termination. There's no outlet. And I think what's happening is they're taking the definition of outlet and they're misinterpreting and misapplying it, because when you go look at other sections of the code, it specifically tells you otherwise. And it's no different than Ryan saying, oh, if I come over and I hit a disconnect for a motor and then I go to a single motor and it's a fusible type disconnect, that's a feeder going over that. No, it isn't. That's a branch circuit. It always has been. And, you know, we've had it in our publications for over 30 years. Nobody's ever questioned saying that was a feeder. It was always pointed as a branch circuit. Now, all of a sudden, everything that we learned all these years and decades, all of a sudden, it's all wrong. I don't think so.
Yeah, and I think that they're trying to kind of make this blanket statement that like makes everything work in the code. And me and James, like when they first came out with this, we're like, no, that makes everything broke if you go off your thing. So that's why we're trying to go in there and put some public inputs in there. You wouldn't believe this, James, but I put an across-the-board exception for all GFCI that doesn't apply to anything that's incompatible, as long as it's listed by UL. And then the other thing I put was an exception if it already has integral personnel protection. So I think that's kind of a good one, because it's like, why do you have to go in A? Why do you have to go in B? Why do you have to go in C? Why do you have to go in D? Why do you have to go in F? Why do you have to go in all these sections? Why can't you just go right in the beginning and just put this exception in there? If you have a water cooler, they took that out of 422, but you have a water cooler that has integral personnel protection, it's exempted.
Right.
So why can't they just put that in 210 and just do everything right across the board? Why can't they just do chapter 2 and just put an exception and just be done with it? Why do we have to go all these different sections? Why do we have to go to 422 then reference back to 210? Why can't we just put it in 210? You know, why are they so scared of putting these exceptions in there? So
it's going to be interesting
awesome.
This next cycle.
They're gonna have some good ones. I hope a few of mine pass, but I actually hope a few of mine fail too. So scavenger hunt is on.
All right, you ready for your tool?
Yes, sir.
All right, let's roll it.
It's time for Tool Review of the Week. Sponsored by Electricians Only Tool Review and Nipex Tradesman.
All right. Well, this tool of the week, you guys probably wouldn't believe this, but I found this tool of the week on James's job site. It looks like he's been using the red a little bit, but it looks like he's been cooling off over there in Texas. 109 today in Houston, I saw. I saw a few of the guys using these, and I thought it was a really good idea, set up on your cart and stuff, and kind of have that extra little fan protection from the heat. That's kind of goes in with a little bit of safety and keeping that air moving. I thought this was a really awesome product. I think next week I'm going to see if DeWalt's got a model that is maybe like 10 times better. But I don't know for sure. I'm just going to have to do some research on it. I actually did see this fan in action the other day, and it seemed like it was moving some air. So I do recommend the Milwaukee M18 cordless Jobsite fan. Seemed like it was doing a great job moving some air. I was stealing a little bit when I was over there. But like I say, I don't know how the battery lasts on it. I'm sure if you put the 9 amp hour in there, it'll probably last pretty good. But like I say, it seemed like a really good product. It was moving a ton of air, and seemed like really good for keeping yourself cool out there and not getting that heat stroke this summer out there on the job site. So I couldn't believe I seen it on your cart, James. I was like, man, I didn't think you used the red. I was like, oh, all right, but I was stealing a little bit of air. It was feeling pretty good.
I'm old school. I'll use whatever works.
There you go. I like it. I didn't know that you stole it from somebody else, but it's all good. Thanks a lot. Love the tool reviews, and like I say, if you guys have products that you like or you want me to cover, just hit me up and I'll toss them in there. Except for Ryobi, Joe Sparky, I don't do Ryobi, so I might do some Ryobi. It'd have to be pretty dang good though.
All right. Well, we got a question of the week. Let's see what you got for me. All right. Let's see here. This one's
I threw a little curveball in there to toss the meters in there, so I know you like that.
Oh, hell, you did do it at meters. Looking at that, 6. I'm going off stuff I know what the meter rating is. That's 3, that's 10, 6. So it should be 2 meters.
Ding, ding, ding. You nailed it. Awesome job this week.
I guess
so there was a lot of people. There was a lot of people. No, I heard you say 6 foot, but which you're right on that. But and the meter conversion, there's a lot of weird measurements. Like it says like 6'6", but I think it's like 6'5" and 7/8. It comes out weird on the conversion, but if you go look in the code, it's exactly 2 meters. So I thought it was pretty hilarious. And then there was people that put 0.5 meters because they thought, well, I wouldn't want my outlet like really high on my balcony or deck. And then there's other people that are talking about like the little accent balcony or deck, and then the inspector makes them put an outlet out there, which receptacle outlet out there, which you really wouldn't need. But it's really awesome that you've been such a good sport and got me to try to fool you on the code all the time. But good guess, and you got it right. But the next one, you're really going to have good guesses. And anybody is welcome to join in and try to, get them right. But like I say, I guarantee that everyone's going to be kicking themselves because they're going to know this one later. But I'm trying to get James on the hot seat here. So
all right,
let's go to the Willie quiz. All right, so we have a great Willie quiz for you. If you guys are out in the chat, anybody out there, you can jump in and have some guesses on this. Try to beat James. This has always been really fun for me. I kind of stole it from some of the other live shows that are out there. Try to get like the audience, people in the chat, to jump in, kind of check it out. So from 2015 to 2019, what was the largest percentage of electrical problems that resulted in electrical fire? I should have put Wagos. Oh man, I missed the boat on putting Wagos in there, but I know you would have picked Wagos. But anyway, we have cord and plug connected, transformers and power supplies, lamps and lamp holders, wiring and related equipment, or holiday temporary lighting. What was the largest percentage of electrical problems that resulted in electrical fire?
I'm going to go with E, holiday and temporary lighting.
That's pretty good. That's a really good one. Actually, if you were to have another answer that you would think was a really good one, besides that one, I mean, E was actually one that wasn't even in the thing. I just added it to
Really?
try to get you.
Well, the reason I went with that, because we've done a lot of cases where houses have caught on fire and people have gotten hurt from. We probably had. The reason I was thinking it was probably for, as they were counting all your older, because a lot of them that we go to, probably the majority of them was because of it was knob and tube wiring. And you have a whole lot of houses like that in different areas of the country that still haven't been updated. And they were having a lot of fires and stuff due to holiday lighting. That's why I actually went with that.
Okay.
So,
Well, E was actually, it wasn't even part of the statistics. I just put it in there because I thought it was funny. I thought it'd get you.
I really, that no matter what you put in, I would have guessed that one. So,
All right.
let's see.
Cool. So basically, E's eliminated now. You have A through D.
I would probably have to go with the lamps and luminaires.
All right. C. James Stallcup locks in the answer of C. All right. So if you were to pick another one out of the three that are left now.
Well, I guess I'd have to go with cord and plug connected.
All right. So James goes locks in with A. Dude, that's really good. I mean, but there's still two answers that
Wiring
have a
and
higher
related equipment.
Yep. Ding, ding, ding. You got it. And did you see how when I put it E, you basically were calling out wiring and related equipment?
Well, the reason I didn't go with that is because I thought it encompassed everything, and I thought we were being more specific, and that's why that would have actually been my first answer, but I thought it was more to specific, not just covering everything, and that's why I didn't go with that. Would have actually been my first answer.
Yeah, and you would have been right if that was since it was your fourth answer, but actually wiring and related equipment was 68%. All the rest was 14% on lamp and bulb, 10% on cord and plug, and then there was 0% on E, holiday temporary lighting. But it was funny. I thought that was a good one to kind of get you kind of going down the wrong track, but that's pretty funny.
That's sort of a question, because it to me, wiring and related equipment covers everything, and I thought it was more specific to what caused the electrical fire, because the way that reads, it says resulted in an electrical fire, and And wiring and equipment system, to me, that covers everything.
Dude, I was almost ready to put F in here and be like COVID, but that would have been too bad. I would have got a lot of hate.
I wouldn't have went with that one.
All right,
Oh
so
God, I have no freaking idea on this one.
So number 2, how many total definitions were in 2020 NEC? Was it under 381? See, I figured out for last week. I figured out how to fool you on these two, because you don't know where I got my number from. Under 381, exactly 381, or over 381?
I'm just trying to go through my head. I mean, I would say it's under 381.
All right. Yeah, I mean, there was quite a bit of definitions in 2020, but if you were to pick between the other two options that are still left, what would you go with?
Well, it's just a guess. I'd say exactly 381.
You nailed it. Exactly. You got it on your second answer. Exactly 381 in the 2020 NEC. So I got you on the exactly. The exactly is a good one, because you kind of question, like, why would you say exactly a certain number?
Well, when I was looking, I was trying to think how many, because I knew there wasn't, because you're going every definition of code, so that's including other definitions throughout the NEC. So I would actually be willing to bet that it's actually, I might even run this next week, how many definitions are in the 2023, and I'd be willing to bet there's under 381 in the 2023. I'd be willing to bet they removed definitions. They did. That's what. Oh, it's 2020. Okay, yeah. I was thinking what they did in the 2023.
So I might get you next week on the.
Yeah, that's okay. These are hard.
It's so much fun, man. I love fooling you. All right, so 2015 and 2019. Which time of day did the highest percentage of electrical fires occur? And to me, like, we actually, at one point in time, this is a long time ago, it's probably like 15 years ago, we actually had a fire at our house. And what happened was, my daughter came home and she had these Rice Krispie treats, and she set them on the oven.
Mm-hmm.
And then she went to bed, and the pilot light was just sitting there on those Rice Krispie treats. And eventually, I mean, those Rice Krispie treats are flammable as hell. Mm-hmm. And it was a big, massive fire in my kitchen. I just woke up and big fire, alarms going off, and my daughter's like, "Shut that alarm off!" And I'm like, "Oh, shut this fire off," you know. But it was pretty bad. But that, I'd say, it was about 4 a.m. when that happened, maybe midnight something. But I'm not trying to give you an answer or anything, but I'm just trying to kind of say that, you know, actually, I'll give you a freebie on this one. Midnight to 4 a.m. was about.
I'm going to go with 8 p.m. to midnight.
8 p.m. to midnight?
Yep.
All right. So, if you were to choose a different one, what would you choose?
That was not it, huh? So, I would go midnight to 4 a.m.
All right, so I was just trying to give you the statistics on that one, which was 11%. The first one you picked, E, was 18%. So if you had a different answer.
4 a.m. to 8 a.m.?
All right, so that was actually 11%. So now you're narrowed it down to 2. You're really close.
So it was done, most of them were after people left for work from 8 a.m. to noon?
Well, that was actually 18%, so that was the same as 8 a.m. to midnight.
Really? 4 p.m. to 8 p.m. while people are at the house is the most fires?
Yep.
Really?
That one caught me by surprise. Like, when I saw that one, I was like, no way. Yeah, 24% were from 4 p.m. to 8 p.m.
I would not have thought that.
Yeah, and who knows? Maybe people are working nights. Maybe they leave at 4 p.m. I don't know, but that to me was crazy. Like when I saw that, I was like, "No way, is that right?" You know, I knew I was gonna get you a little bit on that one. I tried to give you the statistics of the midnight to 4 a.m. You know, it to me, even if there's like a way to cheat, that one there's no way to cheat on. That was a good one.
No,
I got you.
it's like I was saying, I have no idea of those statistics. And, uh,
Yeah.
you know, a lot of people, they think when we're doing the code question of the week that I know the answers already. No, I don't know the answers. I don't
Well,
look
yeah,
them up. And this
and
is a
that
good example. I don't look any of it up.
yeah, and that's a good thing. Like when you guys want to tune in, when we do the Willie quiz, it's basically a guess, so you can just jump in, submit your answer, and like I say, to me personally, I think it's gonna be really fun moving forward. I'll try to keep doing like random trivia on different stuff, and try to get stuff that just nobody really knows. Like
Yeah.
you can Google it, but by the time you Google it, it's gonna be too late because James already is on his second answer by then.
Yeah.
But it's fun. I like how I narrow them down for you, and we can start doing like a 50-50. Like, all right, so you got your first one wrong now. 50%. I was so happy that you picked my first answer that I made up right away. Like I was like, yes. I was like, sweet.
Well, there was a reason that I actually picked it. Because I've dealt with cases like that. We probably have done like here. I think we've done probably like 8 of them, probably that were something it caught on. It was all holiday lighting too, and
Yeah.
every one of the houses were knob and tube, and that's why I was thinking, oh, it's probably something knob and tube, and they're still having fires from that. That's why I went with that. There was a reason I picked it.
So I could see that. I would actually think that'd be a pretty good meme. Like them sitting there doing the fire investigation, like write it up as holiday lighting. Nope, wiring and whatever. Like no, we're not doing that. No, that's just made up.
Well,
But it's one of the I see where it comes from. That they're not gonna say it's temporary lighting. You know
well,
what I mean?
if I would have looked at that and just said that D included everything, then I'd been like, oh, well, naturally that's it. But I thought the way the question was worded, it was specific to certain items, and that's why I went with what I did. Otherwise, I would have picked that as my first one.
I should try to go in and see if there is anything specific on like holiday lighting, and then I could get you next week.
You you should take those and put those on the NEC for Dummies. Just call it random NEC question of the week, and
I like
have
it.
them on and let people guess. I think they'd get a kick out of it.
Yeah, it was a lot of fun to do. Like I say, it's just so fun to fool you, and the whole thing is too that it just goes to show everyone like we don't think we're not like arrogant people out here. We're not just like thinking we're right on everything. Like we are challenging code making panel 2. I feel that they passed 210.8F to basically cover everything. I feel it was a little bit greedy, and I feel that they should have probably just tried to focus on covering just the AC unit. I don't understand why they had to bring this outlet definition into the GFCI protection for personnel. I felt it was a little aggressive when it comes into like protecting personnel, safe installations. We've had these pieces of equipment hardwired on the sides of our houses for years.
No
I mean,
problems.
probably many decades. Never had any problems. Some maintenance crew miswired one. Kid got killed because of it. Why do we have to change the National Electric Code? To me, that's reckless. That's irresponsible. That's to me, it's not it's not ethical, you know. And to me personally, with me coming up in the trade, as everyone knows, I've been a journeyman for 25 years. I've been, I started the trade in the early 90s. I started training under the 94 code, and I was always taught that if you hardwire it, you remove the hazard.
Yep.
I still believe that to this day, that if you have a cord and plug piece of equipment and you hardwire it, you remove the hazard to personnel.
Mm-hmm.
I still believe that to this day. And when I go and read all this stuff with Code Making Panel 2 and with all the substantiations that they've made, I don't agree that they have technical merit. I don't agree that there's a personnel protection problem with hardwired utilization equipment. There could have been for like vending machines. I've heard that there was problems with that in where kids were trying to tip vending machines, and then the vending machine fell over and the cord shorted on and killed them or whatever.
Mm-hmm.
I've heard about all this different stuff, and that could be true. But at the same time, I'm not buying these statistics when, like me and James, we're going on probably 5 years now, 4 or 5 years that we've been arguing the same thing, and there's not a whole bunch pouring in because all these states deleted it. So that's the other thing that's going to be hard with the statistics, because no state, like you look at Nevada, they're not going to enforce 210.8F on AC units. You look at Texas isn't going to enforce 210.8F on AC units. You look at Arizona's not going to enforce 210.8F on AC units. So let's just say those 3 states right there. Out of those 3 states, we don't have a single death because they didn't enforce this code the way that they wanted it enforced. And to me, that's just negligence on their part to pass this and it not even be able to be complied with for how they want it complied with. So what do these jurisdictions do? They just delete it.
That's right.
And that's what's going to happen in the future. And then they're going to sit there and go, we're safety. Okay, well, how safe is it when it's deleted? And that's what I've been trying to bring up this whole time, is when you're just trying to say, oh, well, what's up with this well pump? Clearly this well pump's hardwired. It's, in this situation. Oh, no, Class A protection for personnel. Well, based off what? Oh, our TIA that failed. No, you can't just keep doing that. And you're not making anything safer.
They think they are, but like I said, you have to provide technical merit to why you want to change something and want to require something. And they didn't do that. They cited a death that was improper wiring method and 3 others that was improper maintenance. And that was their basis for it. Had nothing to do with the equipment. And the equipment was listed and labeled to be installed exactly as it is. And let me say this. If the manufacturer wants to come in and put in his instructions and UL's okay with it and gives it the listing and labeling, and they say no GFCI protection, guess what? That overrules whatever Code Making Panel 2 says.
Agreed. And the other thing is, too, if the manufacturer wants to be like super safe and make sure that everyone's installing GFCI protection on it, they can install it in their equipment.
That's right.
And if you pass my proposal for 2026, it's already going to be exempted because it already has Class A protection. So you basically just, punch the bear right in the face and stop.
It wouldn't be Class A protection. It'd be GFPE protection because they'd be protecting equipment.
Per the way that I wrote my proposal, basically if the manufacturer provides protection for personnel, does not have to be Class A.
That's right. Doesn't.
Because the manufacturer says protection of personnel. Doesn't say it has to be Class A.
Just like we were showing for shore, just like we just did, showing it for shore power. It didn't have Class A, it had GFPE. And it specifically talks about the receptacle that's installed where? At the outlet. Now all of a sudden, I don't need it. Come on. You can't have it both ways.
And that's why I put it in my proposal as protection for personnel and not Class A protection, because I feel that water's been getting muddy right now, because they're sitting there saying that GFPE, they're saying GFPE is not compliant with anything that's in 210.8. But what I'm trying to do, not really muddy the waters, but what I'm trying to do is clarify where it can equipment can be exempted from Class A protection if the manufacturer approves it, saying, like, and I don't know if I told you about this, but you look at some of the EBSE equipment, it has like so much safety stuff in it, and so the Code Making Panel 12, big shout out to Code Making Panel 12. You guys did a great job last cycle. Everything in 625 works great. Where's your Class A protection? It's cord and plug connected. It's connected to a receptacle. When it's hardwired, nope, it's good. And the whole thing is, why is that? Because when that EBSE equipment has a special prong on it, that when you're plugging it in, it won't discharge any power until it has like a proof that it's connected with that vehicle. Sure. So, there's so much safety stuff in there. This is not the days of the 60s and 70s where, you're throwing your kid in an asbestos suit so you can smoke cigarettes and ash on him. This is not the same generation these people are trying to push this whole safety standard to. And like I say, me and James have pushed back a lot on these guys. And like I say, sorry to anybody if I hurt your feelings or James hurt your feelings. We're just telling you what the code says. And, if you don't like it, that's fine, you don't have to like it, but, it's the truth. And
everything that I make comments on, there's a reason behind it, and I just, I look at the overall code. I don't pick and choose just because I want something to mean what it says. And there's other parts in the code you have to look at in order to make assumptions based on what other code section says. It just like I was talking about Ryan saying a feeder, no, that can't be, because 430.62A tells you it's 2 or more, and it says a motor and other motors are a motor and other loads. That means it's feeding 2 or more. That's a feeder, and up to this point, I've never heard anybody disagree with that till Ryan's. I was like, that's not right, And this is my reasoning behind it. Not because of what you want the definition to mean. You got to look at other sections in the code where they're more specific what that feeder supplies. And it doesn't supply one single motor.
You kind of have to look at it like the Pythagorean theorem, where you have a triangle. And you're sitting there looking at your triangle. And you're saying, okay, if this is true, then this is true, then that's true. And the thing is, they're just going up there like this and going, hey, ACs are outlets, And it's getting to the point now people aren't believing it because you don't have the other two pieces of that triangle to make the other parts true. You don't have anything to cross-reference it with. You better just believe what they say or just say what they do or whatever, or else you're killing babies and all that. And we have this joke on there where it says Bill lied and kids died, And we're always just joking around. And the thing is, it's like what did I lie about? I just basically showed one guy says it's the disconnect, other guy says it's the unit, and I'm like, why do they have to be over here this far apart? And why is it even an argument in the first place? To me, a hardwired utilization equipment is not connected to an outlet. It says
What?
that there would be no reason for individual branch circuit to say from the final overcurrent device to utilization equipment.
Well, let me say this. They say that Bill lied, kids die. Well, let me ask this question. Well, what if you put GFCI on it? It's in the heat of summer and the breaker trips. The old person doesn't know what to do and they die. Is that your fault too? You know,
Yeah.
and for them to make that kind of statement, that's ridiculous. And
Well, and I talked to you about this too. This was actually a year ago, and it was probably or it was probably less than a year ago because the kids are getting ready to come into school, and I had to get this captive air system up and running and fired up, and I'm thinking about it because they were saying they put it on GFCI per code, and I'm trying to find a code that says they're wrong, and really I couldn't find it because it's a kitchen outlet by their definition,
mhm.
and I'm like, let's see if it works. If it works on GFCI, I'm gonna leave it on GFCI.
Right.
Went over there, turned on, instantly tripped. I'm like, okay, so what are you telling me? I gotta strip the guts out of this Ansel control panel and somehow get the GFCI to hold, and then have all the controls for this thing totally fakied out with no transformers hooked up and nothing, so that the GFCI holds and nothing, like no safety, no other safety in the kitchen is in, because it won't work on a Class A protection. You have to just fakey it out. You have to just pull it off the jumpers and just make it look like it's on there so that GFCI will hold. And then that's safer than, because like I'm saying, now all of a sudden, all this life safety, if there's a fire in that kitchen, there's 300 kids that are going to die. And you're saying, well, no, but it's on GFCI protection. It's on a Class A device, To me, that's where it really hit for me, where I was like, this is asinine. That is not a freaking kitchen outlet.
I'll take it a step further. When you start doing that, you broke the listing and labeling of that equipment.
Yeah, I agree.
That's it.
Well, and it says in there, right on that freaking Ansel control cabinet, it says, do not install on a Class A device.
Yeah.
And I was like, let's see. No load. Nothing on. Everything taken off. Nothing's even turned on. It's got a 24-volt transformer only. Tripped instantly.
Sure it does.
And I mean, there was nothing on. There was no load. There was nothing turned on. It wasn't controlling anything. And I found it interesting, and under all these different interpretations, that would be considered a kitchen outlet, which is stupid, because it's like, it's not an outlet. It's just a freaking control cabinet. And they say, okay, well, burglar alarm, fire alarm, they don't have to be on GFCI protection, but what about Ansel control cabinet and kitchen? That's not in there. I'll have to go in there and put that in for other than dwelling units in 210.8.
Damn. Been up too late.
Yeah, no, dude, awesome show. I appreciate you, sir. And you freaking threw it together. And pretty awesome. Had a bunch of people jumping in. Mike said he had some things going on. He couldn't make it, but it was pretty awesome to just have everyone, check it out. You can check it out whenever you want. And, feel free to hit us up, comments at YouTube channels and stuff like that.
When you look at all the social media and stuff goes to, it's, most people see it after the fact. And there's just thousands upon thousands of people watching the videos and stuff. And, that's what we look at. If you can join, great. If not, watch it at your leisure. I do that on a lot of different things,
Well, I can guarantee that people will be jumping in for the next Willie quiz, because I think I'm going to recycle some of these and kind of maybe reword them and try to get some more things like how many fires are caused by Wagos, because everyone says there's a high percentage that's caused by Wago connectors. So I'm going to go in, I'm going to do some research, and maybe I'll use some of these same numbers and try to see if I could fool you again on the same numbers.
That wouldn't be hard, because those are everything. Every time I do it, it's a freaking guess. I don't know.
Yeah.
I usually have a reason why I pick something, it's just not, I'm just guessing, I have a reason why I'm picking that
Well,
Certainly
and that's
can.
what's fun about getting people in the chat to jump in because they could actually possibly get the right answer, and then we might just have a leaderboard or something like how many people got their second answer right versus your second answer or something.
Yeah.
You know, but it's a lot of fun to do, and I think it was fun how I kind of narrowed it down, and you're like, oh, okay, well, wow, you know, like, but it was just funny how you picked. It's funny because, and you'll get this when you start seeing how I write questions, but I almost always put E as like an extra answer that's not right, as like a purposely misguided. Like I'll say all the above, and then you're just like, wait, all the above, what? You know, like why would you be asking this question for a specific answer and then it's just all the above? You know?
So that's
Dang.
what that first one was. I was like, that basically includes everything.
Oh, David just jumped in, but it's all good, David. Just go through and push pause every time on the Willie quiz, and you'll have fun beating James. But
I didn't
it's
even get
really
one
fun.
right. What are you talking about? You just got to get one.
Hey, all your second answers. Well, one of your second answers is right. Dude, the definition one, that's good. I'm gonna have to go definitions 2023 because I'll get you on that one too, probably.
It's a guess. It's just
Yeah.
a guess.
We'll see because 381 is the exact number for 2020. So you know, I got you a good thing for 2023.
Cool.
I'm just off the top of my head saying that there'd be I say they're gonna be lower than 381 for 2023, but they could have added definitions. I don't know.
I don't know.
Who knows? 2026 they might delete like a whole bunch of definitions. We never know.
We'll look and see. I think that'll be interesting to see if that happens. So
Yeah,
All
that'd
right.
be funny.
let's wrap it
Yeah.
up. I'm hungry. I
All
haven't eaten
right,
today.
well, everyone out there, remember, make every day an easy day.
Everybody have a good weekend. We'll see y'all next week.